The WAGO Interface Configuration software G2 is a tool for parameterization and monitoring of the WAGO measurement transducers and the WAGO power supply units Pro 2. In its new version, the WAGO Interface Configuration software G2 is able to do also a simulation. So even if you do not possess a WAGO Pro 2 power supply unit, you can make advantage of the simulation and get an impression of the capabilities of the Pro 2 power supply units. Now we will have a closer look to the WAGO Interface Configuration software G2. Therefore, we start the software and select, for instance, the 10 amp power supply unit. I'll select a current firmware version and connect to the power supply unit. As you can see here, we have the measurement data as the voltage, the current, and so on. As there is no load connected right now, we have no current flowing, and so no output power. But the interesting thing is we can even disconnect and select, for instance, another power supply unit, here the 40 amp power supply unit with an actual firmware, and go to the settings menu. And in the settings menu, we have, for instance, the possibility to set the output voltage, or we can set the overload behavior. And the interesting thing here is that we can have different overload behaviors in combination. Constant current, if you have a capacitive load, you would usually use a constant current overload behavior. Then we have a hiccup mode, or also the electronic circuit breaker mode, where you can set a trip current and a trip delay. This is suitable if you are, for instance, a machine builder, and you have to follow the machine guideline. Then the standard EN 60204 is important for you, and also the requirements regarding dangerous earth connections or dangerous earth faults. And the requirement says that within 5 seconds, dangerous earth faults shall be shut down. This can be easily done by selecting the electronic circuit breaker mode with its trip current and a trip delay. If I set it here to 5,000 seconds, I'm sure that the output will shut down within this time. Usually, you will use a miniature circuit breaker and the output of the power supply units. If you want to make them trip fast, you need high overcurrents, and this is provided by the so-called top boost, which provides 600% output current for 15 milliseconds, so a high overcurrent to trip these miniature circuit breakers very fast. Then the power boost is also selectable in combination with the electronic circuit breaker mode, and this allows us to have a higher output current for 5 seconds, 150% output current for 5 seconds, suitable if you have a strong starting current, so a strong demand for a current while starting the load, or if you have load changes, fast load changes, then this is very helpful. We use this setting here and go to the simulation. Once we have started the power supply unit, we see here the graphs running with the output voltage and the output current. And here we can set a certain output load, for instance, 50% of 40 amp. That would mean 20 amp load. The output voltage goes a little bit down, but just a few millivolts. This is because of the active droop that was set. This allows us to have a easy parallel connection of power supply outputs. In case the output current increases, the output voltage decreases a little bit. We can also simulate short circuit. And then we see here the top boost, and after a short time, the output will shut down because the ECB mode has shut down the output in order to fulfill the requirements of the EN60204 to shut down dangerous earth connections within these 5 seconds. I'll stop that here, and these measurement data and the status indication on the warnings and the errors, what we see here on the left-hand side, also can be seen here under these 3 buttons. If I click on that, a new window opens and shows you a list of addresses where, for instance, in Modbus RTU, this information can be found in order to help the programmer finding this information back on various protocols. So we make it very easy for the programmer to find the information in his PLC program.